Hi, my name's Trevor, and I work here at Google and been doing a lot with faucet and networks and IoT devices. Um, this talk, I'm going to look at how we're using an open source project to work with testing and qualifying IoT devices for use in commercial buildings. And so this is one specific set of the big world of networking and big world of IoT. And I'm really excited because this is probably the one place where I can have this slide and actually people understand a little bit about what I'm saying. Most places out there have no clue. So you should all be pretty familiar, right, with how faucet, one of its secondary functions is to test network switches to comply against the test suite, right? So what we've done is taken that same idea, right, and pushed it out to this big world of IoT devices. And so it's pretty much the exact same model. DAC is a test suite that runs against some piece of hardware that you plug in, and it tests and generates a report saying, well, you passed all these tests and you failed these tests, go for it, right? So it's the exact same framing around how we work with vendors in an ecosystem. Is just instead of network switches, it's the IoT devices. And then it's also layered on top of faucet, and I'll show that stuff, and it uses the faucet networking pieces to control how we interact with the devices. Specifically in this context, this is what we mean by IoT devices. These are building-oriented systems. So we have things like HVAC, which are the big coolers and heaters that are on the roof, and sometimes they're in the basement. These are literally like giant multi-ton things that are very big and have some decades-old microcontroller on them. More modern things like these other devices, yes, we talk about coffee machines, and wouldn't that be exciting? Lighting control systems. I like to view it as pretty much anything that is electrically wired into a building. It would be great to get it out on the network and magic would happen, right? So this is the context when we talk about IoT devices. Just to mention, right, this is very different than the other two kinds of IoT devices that I see out there, which is more consumer, where if you think about what you have in your home and those kinds of things, it's a very different security model and ecosystem. And the other one is what I think about as an industrial. Imagine you have some millions of oil rigs or something, and you have the exact same thing on all the oil rigs. It's a different ecosystem. Here, it's the enterprise version of this. Just slightly different. So what we have, and this is what you think about, right? When you think about a nice modern office place, a bunch of people sitting around, everything's working, happy, and all modern, and it looks nice, except if you look at the ceiling. But if you look behind the scenes, things are really, 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 really old, even in what you may think of as a modern building. These images are stock images of what goes on, but there are places I've seen where it looks super nice. You go behind the closed doors, and there's puddles on the ground. There's giant buttons that are this big. Some of the technology that goes into buildings now, even, is literally things that have not been updated or touched in 10 years. So the hardware and the software on some of these things is that old and is using crazy old network standards and have security vulnerabilities all over the place. And it's just this really crazy world. And it's really surprising when you get there, because if you work with any kind of modern system, you're used to some semblance of behavioral, it's doing something reasonably modern, but it's a totally different world based off of the legacy that exists. So what we're looking at then is this confluence of buildings, so large structures that have a critical purpose to them. There's a lot of important stuff that goes on inside buildings, and once you start considering security threats, compromise can be significant. Combining that with IoT devices, so all these things that are in the building and connected up. Then the other vector that's important here is big data, essentially, which is, hey, because that leads you down the path of, hey, we have all this stuff, let's put it on the network and do something with it. If you were perfectly happy to have all this stuff not be on the network and never do anything with it, you wouldn't have some of these problems, right? And so the drive behind having big data, everyone wants machine learning and artificial intelligence and all those things behind it, pushes you into this space where now you have security vulnerabilities for all these IoT devices in these buildings. And that's where we are this kind of the target for what we're doing with DAC and the tool that we're building. So the Q in this qualification, And I imagine this is very similar to what happens with network switches and those things. So it's, not, again, it's like the same model there. The focus that we're doing on is qualification, and devices get developed by external vendors. We bring them in and we qualify them. And this is right now a horrifically manual process where literally someone in some room somewhere sits down and goes through this massive checklist of, does it do this properly? Does it do DHCP properly? Is it, does it support IPv6? Does it have open telnet ports? So they have this massive list that they have to go through and manually check off yes or no on the things. And then if it passes that, it gets installed in a building. And the thing here, right, is you qualify one switch, one device, one version of that. Then you install 100 of them or 1,000 of them in a building. Nothing, that one thing you qualified says nothing about those thousands of things that you just installed. And there is, literal armies of contractors that come in and install all these things. And one person is responsible for the lights. One person will be responsible for the light switches. Someone else is responsible for the heating things. And it just, it's all over the place. So it's very inconsistent, and a lot of errors can creep in just in terms of configuration. And then the last phase of this is operation, which is fine. You have all the stuff updated in there, installed in the building, and now you, upgrade your firmware. You could have just introduced security problems into the building that way, right? So even once things are installed and qualified, there's another phase of this where you want to be able to test this stuff in situ in an operating building. So yeah, this is the same process, just a slightly different visualization around it. So on one end, we have this big ecosystem of devices, and I think, I forget the exact numbers, but globally, when we're working through this, there are easily 10 or 20 different major manufacturers of things. With each one of them has many, many different devices. So you're talking hundreds of thousands, I think, if I did the math right, different kinds of devices. It's a very heterogeneous situation. So huge amounts of diversity. There's no way you're going to get people to manually test all this stuff effectively, right? So and this is where the automation comes into play and what we're doing there. And it gets, like I said, narrowed down to a few things you qualify, and then installed system, again, you're back up to large numbers of things, different kinds of it, because now you're dealing with 1,000 things that have been installed in one building, and how you're testing that. So this is the basic setup that we're working with. So there's a faucet network infrastructure, and I go into a little bit more detail about exactly what our architecture is there. You plug your devices in on one side of the switch. The framework sitting on the other side, it does the thing. It looks at the events coming in of the learned new MAC address. It does some rewriting of files to change the ACLs around and VLANs to get faucet to do the right thing. And then it runs through a series of test modules and just reports results after each of those tests. And then there's some external connections. Some of these devices have to reach out to the internet to do some things occasionally. And so we can let that happen and track it and monitor and test that as well. Here's a list of the tests that were currently available. So DAC is an open source project, and it's out there. And these are these tests that are currently available on the open source world. Initially, most of them are some of these basic network ones, getting into PoE support and connections, and just, are these things doing basic things properly? And basic functionality that you would just assume is there, which is not there, starting to normalize the ecosystem around that. There's another set of tests then, which are security oriented, which are the, start off with some of the obvious ones: brute force attacks on passwords, port scanning, proper support for certificates and all that stuff. Just getting those basic security principles in play and testing that. There's another layer of tests then. You can see we were getting from massive amount of networking things down to smaller and smaller numbers of things that we're tracking into these buckets. So application level things. BACnet is a fairly old protocol that all these things use to talk to each other. And then we just want to make sure that it's compliant with even some of the basic BACnet specifications. So you're starting to get into some of these application specific things, but they are so common that they hit, in some places will hit 80% of everything in a building. So they're worthwhile to test And then there's another layer that is on top of this pyramid, which is if you think about software-defined networking, right? And it had this fundamental shift in how you are dealing with networks in a building, just networks in general, right? Where, okay, you have this thing and now you're programming it from some external source and you can much better control what it does. We're trying to instill that same vision and principles on an entire building's worth of stuff, right? Not just the networking, but everything in the building. And trying to shift how people think about all these devices. And it's a huge mental shift for them. They are used to these devices where you literally have someone walk into the building, plug their serial cord in, program the thing. Firmware updates are done that way. All this stuff is doing local communication. Shift it around, saying, hey, let's program you from the cloud. This is, again, getting at the big data in a much more secure and operational way. But that's a fairly, that's a tip of the iceberg thing that we're only barely starting with now. But it is the big vision where we want to take a lot of this stuff with these devices. And here's the network model, what it looks like for each device. So how this works is you get your switch, and you can get a 48-port switch or a 6-port switch or whatever, and plug your devices in. And then so each one then, this is where it gets in and fiddles with faucet to do the right thing, sequesters that device from all the other devices. So you can simultaneously test 40 devices at once by just plugging them into different ports. Each one gets its own instance of test modules, a gateway, doing some basic things. This is all done with Docker containers and all those fun things. And it creates this little world for this device, and then it tests it, runs through this just big list of tests, and spits out the result. So this is how it basically works. There's some advanced provisions when we start thinking about where things need to go with this, which is you can then start testing groups of devices. Because when you actually look at what you want to test, it's like, well, I have these two devices. Not only do I want to test this device, I want to test it. This device said it needs to talk to this other device using this very specific thing, but not these other things. And so you actually do want to get in there and test groups of these devices and how they form little micro networks. I don't know what the right term is, with each other in that. And that's something we're working towards, and that's the big vision behind this. And so, but for the most part, it's about testing one device and its isolation and just how it behaves. So then the progression that the system works with, and this gets into where Faucet has really been helpful in terms of controlling all the stuff and using OVS and physical switches and all these various things, a little bit similar to some of the other talks. And there's one world, of course, if you're in completely software engineering land, you are dealing with zero physical devices. Everything's continuous integration testing. It has faux devices for things that behave however we tell them to test positive and negative cases. Then there's the second case, which is where I just want to test one device. And here we don't actually need to use physical network switches. You can get your USB Ethernet dongle, plug one device in, does everything internally, and test that. This primarily comes up in two cases, right? One is the quick start, which is I just want to play around with the system and test my one device. It's just much simpler that way. The other cases, though, as I mentioned, some of these devices are really big. Ideally, you would have your lab set up. You order some of the devices, get them shipped in there, install them. Oh, hey. It's showing fun in my screen. Huh. All right, then. Wow, and now I'm realizing these colors are really bad on this screen. So the other case, which is where you want to actually go on site and test something. And so instead of you have your qualification lab where people send devices, someone tests them all, yay. Sometimes you actually either have to go on site, so in the basement of some building where this thing was driven in by a truck or lifted in by a helicopter or some of these crazy things like that, or you go to the factory where it's being produced and test it there. And so it allows you to have this kit, which is like I can go there with my laptop, plug the thing in and test it. without having to move a lot of systems around. There's another level of testing, which is primarily where we're at now, which is when you're dealing with 10 or so devices. And this is where you get your switch, like the picture I had there, and just plug your devices in, simultaneously test them, increases your throughput, and you can do a lot more that way. Looking forward, what we want to do right then is, as I mentioned, test things in situ in a building. And the Plug Fest yesterday was doing the same architecture with a bunch of switches and crossed around, which is hundreds of devices now that you have multiple switches that you're plugging things into. And this is the added feature here that we want to start getting at, which is, well, here is your network that is operating in a production mode, and you want to take that one device over there, take it offline for a little bit so you can test it just in isolation where everything else is still operating. You don't have to physically rewire anything. And this is where then again DAC is going to have to get in there and start fiddling with Faucet to control all the ACLs and settings at runtime. A little bit like what Poseidon was doing, right? You get in there and you're starting to change things as things happen. Same general idea. There's another world then, right, where you start to get to 1,000 things connected on there. And I'm pretty sure the model is going to change at that point. Something, this doesn't quite smell right for doing that level of system. It just may be multiple instances of the same thing. I don't know. But that's the direction where we're headed in terms of integration with production systems and Faucet running those systems as well. So another key part of this, which finding is one of the key value adds that we need to put more attention into, because there's certain challenges we run into where there's something new that's out there. And like I said, some of these devices are 10 years old. People have been working on them, are embedded engineers who have been working for a long time and don't know what all this new stuff is. And you tell them, okay, do this new thing. And they're like, I don't know what that is. And it's a pretty boring conversation after that point. This is just one example of something like this, is where we're trying to get them to do something new. And I imagine the closest parallel with Faucet is, okay, we want people to implement OpenFlow. And you can go read the OpenFlow spec, which is, I don't know how long, but it's a very daunting task just to say, do this thing, come back to me when it works. So this one example, which is this thing called MUD, Manufacturer Usage Description, which is a recently approved IETF spec. And it's basically a reasonably simple profile around a device that says this device has these ports open for this thing, these ports open for this other thing, these ports in, these ports out, TCP, UDP, all that stuff. Just a pretty basic network skin around the device specified in a standard format. And what we want is we want all of our device manufacturers to do this. And that seems like a fairly simple thing, except if you actually look at the spec, it's 60 pages long. It specifies all sorts of corner cases that we don't care about. It has nifty things like you can just say, allow everything on the local network, which works, sure. And it is a valid MUD file, but it's not what we want. And so we get into this place, right, where we're looking for this partial compliance with this new spec that people don't understand. And we really need this, again, simple testing way where they can do what they think is right, plug it in, and it sees yes or no. And they keep figuring it out until it says yes. And then we can start to work with them that way, right? So this is another very important aspect of what we're doing, which is pushing on these new standards, which is different than, if you tell somebody, okay, please implement DHCP properly, they at least have more of a grounding for what that means. It's much more expected. So there's another layer here too, when, get into, like I mentioned a little bit around, okay, we have these two devices that are connecting. How are these two devices connecting with each other? We need this other thing, which is this device schema, which says that A and B are connected, but not B and C. How does that play out? Again, totally undefined specification that we have to come up with and then somehow get people to implement out there in the world. So this is a vector for doing that. We just give them a tool, says this will test it, programs their Faucet switches to do the right thing, keep fiddling with it till it works, right? And this is my little poem that I came up with this. Implement MUD, not everything, and just the parts we want. So it's and this is just one example. There's a couple of other things. Like I mentioned, this concept of doing the software-defined buildings and what that means. Exact same thing. It's a nice idea, but you can't just go to someone and say, hey, make your device do software-defined buildings. They don't know what that means, so nothing will happen. So by codifying it in these tests, we're able to just define the future and push it out that way. So from the basic foundations, so like I said, the basic place we're starting with this and where our initial sweet spot is and what we've been working with primarily is this qualification process. So this is literally labs that are set up, and we have a couple of them set up globally, where manufacturers send their devices, if they can fit in a box, and they test them. And it's some mix of manual and automatic now. So this process exists, and we're essentially optimizing with automated tests as opposed to manual tests. That's the baseline where we're starting. And because that right now is the major pain point that we're experiencing in terms of getting enough of these devices qualified to go into our buildings in an appropriate way. So 3 different directions we're headed with that, right? So one is extending the test coverage. Given if you're at, still have a lot of manual tests, we can start automating more and more and more of those, and just improve the overall velocity of doing this, improve the ability to iterate on design changes with the vendors, do all this stuff. And that leaves us, once you have more test coverage, also looking at doing the test-driven device development. And this is pushing this qualification framework out to the device manufacturers. So slightly different than the qualification labs, because the qualification labs are people we are paying to qualify all these devices for us, right? But we also then want to get it out there so device manufacturers can do this and test all their devices. The catch there is that everyone realizes security is important. No one goes around and says security is not important. People don't know what that means. They don't know what to do. So there's actually a couple of people that are starting to catch on to this, and it's like, oh, wait a second. If we use this tool and we make our devices better, we can just turn around to anybody we sell these things to and say, the security is better and it has all these things, right? It actually does help them a fair bit in terms of understanding what good security is in these contexts, in a way, and explain it to people for them to work with their extended customer base. Then the other direction, right, is this in situ automated testing, where take these things, run them in the building for perpetuity in terms of any upgrades and firmwares and all those things that change that we want to test. So that's the shotgun overview there. So yeah, we're trying to get in there and fix this sea of crazy things. And it's, the duality with Faucet is interesting in that I said one is it's applying the same philosophy of test-driven development and getting that out into, how to make the system overall more effective, but then also using Faucet to control the system to fiddle with the various device configurations when we're testing them. So, yeah.
I know nothing about mud, so.
Yeah.
Does mud include some kind of executable specification that have a language by which you can express capabilities and restrictions such that you can write a tool or a compiler around it, either to Faucet or into your TQ, such that you can literally, the mud language becomes a contract for an IoT.
So it is a JSON specification. So it is that structure, and it really does say, here's the inbound ACLs. It's valid. You can have semantic names around it. It allows TCP port 23. It's at that level. So it's not quite, something more complex with that. That said, there is a layer that's needed on top of this, right? Because as soon as you get to multiple devices, and that model, by the way, it's initially intended and works really well for, here's a device that talks out to various things in the internet. Like every Nest camera talks to the same endpoint, you're done, right? Or they just say, fine, you can talk on the local network, you're done, right? We have stricter requirements than that. And then specifically a building schema that says on how these devices are connected together, which is a little bit more like what I think you're getting at, right? Which is how these things then are hooked together. So
in theory, you could write a tool or a mud compiler which become something that
yeah, and that's essentially what the path is, right? You compile a mud file down to a ACL, in this case a Faucet one. It's just as soon as you get to any kind of host resolution around which MAC addresses you allow or IP addresses, then you need more information, which is another input to the compiler. Yeah.
Doing
Yeah.
anything related to provisioning of it is one of the challenges with IoT devices. I mean,
Yeah.
most of them is how do you get the certificates? Whether it needs an IP or
Yeah.
not.
So the thing we're doing with Arrow is basically testing that is provisioned correctly. So that's what we're doing, because exactly that, right? You throw a bunch of contractors at this and they really just want to get in there, provision the device and go home. They will do just what they need to do to think it's done and get it working, right? So yeah, we're going down this path of basically then, the simplest model is you stick a QR code on the device, you have a phone app, you scan the QR code, it loops back around through all the infrastructure to the testing stuff, and it's testing that yes, the device that you just scanned the QR code for did pass all of these tests, which include as much as possible any of the provisioning pieces that are there, right? The tricky part comes when it's application specific, which we're not doing. So if you're talking about general behaviors and general stuff, then yes, application specific is just going to be too much for what we're trying to do. So yeah.
So one way that switch testing everything except but you could potentially virtually plug in devices and build it into your test lab without all the travel.
Yeah, and it kind of there's a bunch of different things threw in there that are all variants of tunneling and getting because theoretically right now this stuff is expected to run on the same system as the faucet controller, but you could tunnel a lot of the stuff and have it running in the cloud somewhere, right? That's one version of that. We haven't really looked at tunneling into non-faucet networks, just because our faucet network is the front line, and so we're looking at pretty much controlling that. But it is effectively tunneling from that to the DAC instance, as opposed to the normal path out, and just kind of redirecting some of those streams. And that's fundamentally what it has to do to operate these things.
I use the same thing, wired physical.
Uh-huh.
It's like
Right.
it turns out.
Yeah.
I'm just curious, there's a lot of parallels between industrial control systems and manufacturing, because there's a lot of IT in that space. Have you looked at this as an application in that space?
No. Every time we kind of get near kind of the manufacturing side or any of the industrial side, the story is just different, because they're like, we have 1,000 of these things, that we built that we're putting out there, and they're much more of this. We are producing a thing then that we are controlling, and so the heterogeneity in the system isn't there, and you're not dealing with quite so many different vendors, and so the scale is really big, but it tends to be much more homogeneous. That's just been my experience every time I sniff in that direction. I have not done any kind of actual investigation into it. It's just none of those. Anytime I kind of come across it, it never has a interesting conversation that comes out of it. So.
I've run across a few recently that have a lot of challenges with legacy devices. You've got like a 0 system running a robot, and if you
Yeah.
change it, you're going to make the laser type robot angry. So
Yeah.
trying to.
And there's no reason, right? If this thing becomes easy enough to use, right, and is available out there, that people wouldn't be able to plug their stuff in and test it. It's not going to hurt anything. It just isn't as the pressing, burning issue that they have, from what I can tell. So yeah, all right.
Okay,
Yeah, thank you.